Okay, so today we're going to actually switch gears completely. In 4.1, we talked about definitions. We talked about, just graphing. How does leading coefficient and degree help us sketch some graphs? And now in section 4.2, we're going to completely move away from graphs. And we're going to talk about just basic adding, subtracting, and multiplying polynomials. So this should be like, an Algebra 1 review. Don't overthink things. When we add and subtract polynomials, we are combining like terms. Now, what makes something a like term? You have to have the same variable exponents. So like if you have 3x squared minus 5x squared, those are like terms. Okay, and you combine them, and it becomes negative 2x squared. So we should probably write down what we're doing is we are subtracting the coefficients, right, and keep the same exponent. So combining like terms means you keep exponents the same. Okay. When we multiply, right, we're doing something different. So this will be something like 3x squared times 5x squared. And so what you'll do is you'll do 3 times 3 is 15, and then you'll do how many x's do we have now, right? So then you have x squared is 2 of them, and then you have 2 more. So it's really 2 plus 2, which is 15x to the 4th. Maybe I could write 3 times 5 here. Okay, so I don't need you to show this part, obviously. This is like the extra, but that's really what's happening. So when we multiply polynomials, we are multiplying the coefficients and then adding the exponents. Okay, so the hardest part for students, it's not that they don't know what to do, it's that you have to identify, are we adding, subtracting, or multiplying? And I'm going to mix them all up. So the first thing I want you to do is identify, we are adding here, we are subtracting here, and then we are multiplying here. Okay? So if we are adding, we are never going to multiply. If we are subtracting, we are never going to multiply. It's only when we're multiplying that we multiply. Okay? So when we're adding these things together, it's just combining like terms. So you can just take away the parentheses. And let me rewrite it. So it's really negative 4x squared minus 6x plus 18 plus, and then anything we add is almost like the plus doesn't matter anymore, right? So then we have negative x squared plus 7x plus 8 here. I'll write the plus and then we can cross it out. So now we combine like terms. We have negative 4x squared, negative x squared. There's an invisible 1. So I'll be negative 5x squared. We have our next term. Negative 6 plus 7 is plus x. Right? And then we have 18 and 8, which is 26. Please make sure you're in standard form. That's really important. Okay? This one, students always mess up because they try to take it easy and take shortcuts. Okay? Please multiply or distribute the negative. That means you're switching, okay? It means it's the opposite of all of these. So really what we have right now is this, but then we're going to have plus x squared, and I'm just going to line them up over here, plus 24x, and then minus 63. And do you see how like I switch the signs? Not because it's on the opposite side of an equal sign, but because this negative says the opposite. And then another way you can do things is combine up and down. So this is 7x squared plus 12x minus Did I mess this up? Oh, I did mess it up. I didn't switch the signs. So that positive 24 has to become a negative 24. Sorry about that. Don't make my mistake. Maybe I should highlight these, because that's exactly what you guys are going to do. Ready? So negative x squared becomes a positive x squared. The positive 24 becomes a negative, and the negative 63 becomes a positive. Sorry about that. Good thing I checked. It'll be minus 36x plus 111. Okay. Multiplication, we've been doing these already just with smaller exponents. So 3x squared times this, and this. Now, I'm just going to do a box method, because what happens sometimes is students lose track of how many terms there are. Okay, so this will be 3x squared here. And then I'm going to fill in 3x squared times 2x to the third is 6x to the fifth, because there's 5 x's total. Multiply in front, so 3 times negative 1 is negative 3. And then there's 2 x's here, 2 more, total of 4. And then 3 times 3 is 9. There's 1x here and 2 here, total of 3. And negative 5 times 3 is negative 15x squared. How do I check to make sure my answer is correct? Well, I go back and I check my exponents. It goes 3, 2, 1, 0. That means these should always also go down one by one, right? 5, 4, 3, 2. And it makes sense. Okay? Example 4. X plus 2 cubed. Please don't tell me this is x to the third power. So I'm going to write in here. It does not equal to x to the third plus 2 to the third. Okay, do not ever do that. What you need to do is write it out 3 times. X plus 2, x plus 2, and x plus 2. Okay? And I know it seems like a pain, but you're going to take it 2 at a time. Please don't distribute to like all 3. Okay, so do 2 at a time. It's like if you had like 2 times 2 times 2, you would not say 2 times 2 and then 2 times 2, right? You wouldn't distribute twice. You just go in order. 2 times 2, do those first, then times 2. So x squared plus 2x, I'll do that in FOIL. X squared, x times 2 is 2x, and x times 2, so that's 4x plus 4. Now, this is where I strongly recommend that you do a box method, just because now we have 6 things that are going to multiply out, right? Because we're going to take this x squared plus 4x plus 4, and then we're also going to take x plus 2. And it just starts to get messy if you go side by side, right? Because if you have 6 numbers that you have to write out, you might lose track of one of your numbers. But this way, you know exactly which ones you've already used. X squared times 2 is 2x squared. 4x times x is 4x squared. They're never the same if you have an extra x, right? 4 times x is 4x. And then 2 times 4x is 8x, and 2 times 4 is 8. Let's put some signs in there. Okay, so now we want to just write things out and combine like terms. Notice, these are my like terms. Okay, so our final answer is going to be x cubed. You'll never combine that first one. Okay, if you do, something went wrong. 4x squared plus 2x squared is 6x squared. And then 4x plus 8x is 12x plus 8. We're done. Okay, so once we've done all that, there's actually special patterns that work much more quickly than others. And so let's establish what these special patterns are. Okay, sum and difference. If we have a plus b times a minus b, remember we talked about that being the conjugate, and if there's a plus and a minus, the middle terms always cancel out, so it's going to become a squared minus b squared. Now if you know this pattern, then instead of distributing and canceling things out, you can go straight to x squared minus 9. And this only works if there's a plus or a minus though. Okay, so it has to be sum and difference. I'm going to highlight this. Okay. That means this is going to be x squared minus 25. And then this is 2x times 2x, which is 4x squared. And we can ignore the middle terms because they're going to cancel. But then we have negative 10 times positive 10, which is negative 100. The square of a binomial is a plus b squared. Or you can write a minus b squared. Okay? There is a special pattern to this as well. This was our complete the square formula. You guys remember, like, we always have like a squared and then b squared. And the middle term, in order to get this, we had to cut the middle term in half, so we have to double this one. So this is always plus 2ab. Okay, so if a is y and b is 4, then I know that I'm going to have a squared is y squared plus 2 times y times 4. And if you can do that in your head, great. And then this will be, plus 4 squared. Okay, so that's really y squared plus 8y plus 16. You see how like we took our y, a times b, and we doubled it. So it's instead of 4y, it's 8y. So let's do this. Let's see if we can do this one in our head. Ready? We're going to take the first term squared. That's 4t squared. Be careful, it's not 2t squared, right? 2 times 2. We're going to double what a times b is. So that's negative 10t doubled. So that's negative 20t. And then negative 5 times negative 5 is positive 25. Okay, and that's just like a shortcut where you don't have to write it out and distribute. Notice in this case, what I did is I took negative 5 times 2, so that gave me negative 20. You can also think of it as it's going to be negative 2ab plus b squared. Okay, I don't like to think of it as two different ones, so I sort of like to ignore this and just consider b equals negative 5 and a equals 2t. Okay, try these two yourself. See if you get the right answer. Okay. And then let's see. Cube of a binomial is a plus b cubed. And this is a different formula. For right now, you're going to memorize it, but soon you will not. So we're going to have 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed. Okay. This is sort of a pain right now, but let's talk about what happens so you can memorize these better. Ready? So we have a cubed, the next one is a squared, the next one is a, and the next one has no a. If you look at your b variables, right, or b exponents, we start with b to the third power at the end, and it goes b to the third, b squared, b to the 1, and no b's. So we're sort of working our way backwards. This one is a little bit trickier, so let's write this out. You guys ready? So this is going to be, we're going to set up our 1, 3, 3, and 1. And so a cubed, a is equal to z. So I know I'm going to have z to the third power. Okay. My next one has a squared, so that's z squared. And the next one has a, so it's just z to the 1 power. And then this one is z to the 0 power, technically. That's where it shows up. But we know z to the 0 power is just 1, right? So it doesn't matter. Then I'm going to plug in b equals 4 here. And then I'll do it in a different color for b's. So that's 4 to the third power, 4 squared, 4 to the 1, and then this one is 4 to the 0. Okay. So now if you simplify, 4 to the 0 is just 1. Okay, and z to the 0 is just 1. So 1 times z cubed is just z to the third power. Then our next one will be 3 times 4, which is 12, z squared. Okay. our next one then will be 3 times 4 squared. 4 squared is 16. Let's write that up there. So 3 times 16 is 48, and there's only one z. Look, it's in descending order, right? Standard form. And then the last one is 1 times 1 times 4 cubed is 64. So plus 64. I'm a little low on space here, so that's our first answer. Okay? So let's do it again with this one, and then maybe you guys can try those on your own. Next year I'll give a little more space. So let's set it up. Ready? It's always 1, 3, 3, 1. So we're going to have 1 plus 3 plus 3 plus 1. Okay. Our A is equal to 3m, and our B is equal to negative 2. So I'm going to set up 3m, 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 and 3m. And then I'm going to go for my, oh, I failed. Sorry, guys. This was supposed to be cubed. Can you change it on your practice problems? I copied and pasted from somewhere else. Please change those two both to cubes. Okay. So then I'm going to look at my exponent, and it should start with 3, 2, 1, 0. And then we're going to put in negative 2 for each of them. And our exponents are going to go 3, 2, 1, 0, but backwards now. 3, 2, 1, 0. Okay, so zeros are gone. They're just ones. 3m cubed. Now, we have to be really careful here. That's 3m times 3m times 3m. So that's not 3m cubed. That's 3 times 3 times 3, which is 27m cubed. Plus m squared is 9m squared times 3, so another 27m squared. Ooh, I forgot times negative 2, so that's negative 54m squared. Okay, so you have 3m squared, and 2. If you want, you can also write it out. So then I have 3 times 3 times negative 2 squared, which is 4. Okay, so 3 times 3, I'll write it over here. So that's 9 times 4 is 36. Negative 2 times negative 2 is positive 4, right? And then I have m. And then I have negative 2 times negative 2 times negative 2 to the third power, which is negative 8. If you guys do something with a negative correct, it should always alternate positive, negative, positive, negative. Okay, I do want you to try, maybe just do the last one. Okay, you don't have space for this one, so let's cross that one out. We'll do the last one only. Do it yourself, and we'll check it in class tomorrow.